Okay, very good. Good. Okay then. Okay. So right, next. Thermometric properties. Okay. Thermometric properties. Yes, good morning, good morning, good morning. Uh, Before this, what was happening? Means I'm live since 5 minutes, but I think some screen not clear, or some problem is there. Not clear. Okay, listen. So you are not going to offline? Uh, no, no. Only in the voice. You came live just now. But before, okay, I am live since 5 minutes, and some people were having some irrelevant discussions. They were having their own discussions were going on. Just now I came live. Okay. Okay. Maybe somewhere, okay, software glitch. I was getting frustrated. What is happening here? Okay, no one is listening to me. They are doing something else. What's going on? Okay, I completed one topic also. One topic also I completed these 5 minutes. I completed graphs because I was asking. We know the graphs. We have done the graphs. People were saying yes, yes, done. Okay, listen here. I just plotted the graphs. Okay, now listen. So thermometric properties basically, whatever the properties, okay. Okay, no problem. We'll do the graphs again. Okay, we'll do the graphs again. Sometimes, okay, okay. Sometimes glitch are there. Okay, so okay. That's why I was thinking also that no one is responding. They are okay, having their own chit chat. Now it is visible on my screen also that maybe some problem was there. So okay, graph will do, okay? Graph will do just after this, no problem. Thermometric properties means which properties, property which will change with the temperature. Means wherever we are changing the temperature, these properties will change and we can find, okay? We can find that change, and using that change, we can get our temperature. So, okay, today is the last for online classes. Now let's complete the things first. So we can say we can use a length. Okay, you can say we can use length, we can use the volume. So length will be changed with the temperature. Okay, but you will ask, sir, length of the solid can I use practically? Theoretically, we can use length of the solid because whenever you will change temperature, length of the solid will change. But practically, is it possible to use length of the solid? No, because change is very less. So we cannot use to make our thermometer. Okay, to make our thermometer, we cannot use this one. Okay, so here we write length of liquid column we can use. Okay, length of liquid column. Okay, like in the mercury, okay, thermometer we use this one. Number two, we can write, okay, we can use volume of the gas also. So volume of gas, okay, but volume of the gas we are keeping at the constant pressure, and you will get to know that volume of the gas at the constant pressure we can use the relation actually V proportional to T. Okay, so we can, wherever any significant change in the temperature, we can find the, okay, change in volume. Yes. Then we can say number three here basically, okay, then the, okay, pressure of, okay, pressure of gas at constant volume, and then we can say this one is basically your P proportional to T. Okay, now we can write length volume pressure we can use. Okay, Here we can use okay, sometimes resistance also in the okay current electricity chapter we'll see. So resistance of wire also can be used. Okay, resistance of wire. Okay, platinum is quite sensitive for the temperature, so we can use platinum resistance thermometer. Okay, yes. So we can say resistance of wire we can use. There are so many thermometric properties. I cannot write all because ultimately, okay, no one is asking also. At least these we can keep in our mind. Now, how questions will be coming out this one? So whenever they are going to ask the question, you need to focus on the language. Ultimately, language is more important. That language you need to always translate into figure. Okay, that is the okay first thing we need to do. So they will say that at 0 degrees Celsius, because you know whenever we have to make any scale, we need lower as well as upper point. So they will say at 0 degrees Celsius, length is L naught, and at 100 degrees Celsius, length is L, okay, 100 here. Some values will be given to you 3 centimeter, 4 centimeter, 10 centimeter. At any particular temperature, we are getting length as LT. Now we need to find this temperature. You will use the same method that we have done earlier. This minus this means we can write LT minus L naught divided by, we can write L 100 minus L naught equal to, we can write here in this point, T minus 0 T divided by 100. And you don't have to mug up this formula. Whenever question coming, you need to just translate like this and then you will, okay, proceed this way. Suppose if I say same question for the resistance, they will use the word platinum resistance thermometer, and we can say for this one, okay, they will say resistance at the 0 degrees Celsius. So we can say this one is the R naught. At 100 degrees Celsius, we can say this is the R100. At any temperature, we can say this is T. Okay. At any temperature, they will say resistance is T. Now we have to find, so we can use the same thing here. RT minus R naught. So we can write RT minus R naught divided by, okay, same process. R100 minus R naught equal to, here we write T by 100. Okay. Suppose I'm giving language here in this one. They are saying at 0 degrees Celsius resistance is, at 0 degrees Celsius resistance is 80 ohm. At 100 degrees Celsius resistance is 90 ohm. Find temperature, find temperature at which resistance is, okay, at which resistance is 86 ohm. This is the, okay, T. Can you find this question? What will be the language given here? At 0 degrees Celsius, resistance is 80. At 100 degrees Celsius, 90. Then what is the basically temperature at which it is the 86? T you have to find. What is the answer? Answer is same process you have to use that we are, okay, here written. You don't have to remember any of the formula here. Just use the process, get the answer. Answer is 60. Yes. Answer we get 60 degrees Celsius, because you will write 86 minus 80, that will be the 6 divided by 90 minus 80 will be the 10 equal to, we get T minus 0, that is the 10 divided by, we can write here 100 minus 0 is the 100. So 0 0 we can cancel. So T becomes here 60 degree Celsius. Okay. Yes. Which topic in NCERT? Thermal properties of matter. In NCERT, these things not given. I'm not saying that these things are very important, but can be, if anyone want to ask, we should know at least. Okay. Thermal properties of matter in NCERT, they have given just okay, 1 page and 1 page, 2 pages on the expansion, 3 pages. It is okay. Expansion in this thermometry is over. What I'm saying here, listen again. Okay. Suharshita, they will say 0 degrees Celsius, this is the resistance. 100 degrees Celsius, this is the resistance. At T, this is the resistance. So we have to find this temperature T. So we can write 86 minus 80, that is the 6, divided by 90 minus 80, that is the 10. Here T minus 0 divided by your, okay, 100. Can we do this thing? Okay. Okay, so now I will tell the graphs basically, because graphs are okay, actually important. We need to know graphs you have done also. Okay, basic mathematics you are doing graph and graph and graph. Okay, so I hope you have clear idea of straight line graphs. Y equal to mx plus c. So in y equal to mx plus c, but still if you don't have that idea, in 2 minutes I will tell and you have to get full idea here. So we can say C can be positive or negative. C is basically your intercept on the y-axis, okay? So if C positive, then I have to move upside, okay? Upside here, okay? This is a 0. Upside means C positive. Downside means C negative. So C positive is here. C negative is here. C 0 means at the origin here, okay? So C positive, C negative, and then, okay, C 0 here. If M is positive, then I will extend my this hand, okay? This one. And I will, okay, draw like this side. So this side, okay, I will draw this side, so this will be the your like this, okay? So all these lines are having your slope positive or negative. If I draw like this, all these heads, okay? If I draw like this, these are your positive slope, okay? If I extend like this, okay, right side. And if I extend the left side here, okay, this one, okay? If I extend the left side like this, okay, then we can say all these lines, okay, are having basically your positive or negative slope. These are having your negative slope. Clear? Okay, so slope we are clear. Slope means your M. M positive, I have to do, okay, do like this. M negative, I have to do like this, okay. M positive, extend this hand. M negative, extend this hand, okay. So these two things are required. M positive, M negative, C positive up, C negative down, okay. So I will now ask something. Suppose you got C is positive, okay. So in the question I am getting here C positive and M positive. So you can say, sir, graph will be like this. C positive, so upside, and M positive, so I will put like this. Clear? Suppose coming here C positive, this is the number 1, okay. C positive, M negative. So you will say, sir, C positive, I will go upside, and M negative, then I will, okay, this side I will put the graph. This is the graph. I hope these two graphs are clear. Yes. Number 3, if I say C negative, M positive. So you'll say, sir, C negative, M positive is C negative is down, and M positive is like this. Then we can see number 4 here, C negative, M negative. Then what will do? Because C negative is down and M negative is how to put this side. So your graph will be like this. I hope these 4 graphs are clear now. Because based on this only, I have to whatever the graphs are coming now. Based this thing we should know. Already whole week, 1 week you have done the graphs. Okay. That cannot be equal, okay, these 2 minutes cannot be equal to that whole, okay, whatever the lectures you have taken, means maybe 3 hour 4 hour practice you have done, but still, okay, for the revision, okay, in short I said this thing, I hope you can. So question is here, they are asking what the graph between F and C, okay. So we need to write the relation here. So relation is F equal to 1.8 C plus 32, that already we know. Now we can say in this way, F is on the y-axis and C Celsius is basically, this is the degree Celsius, okay. So degree Celsius on the x-axis. So I will put here this one y equal to 1.8x plus 32. You can say, sir, this is same as y equal to mx plus c. And now we can compare here, sir, c is plus 32, which is the positive. And if I say slope, which is the actually 10 theta. Or we can say M, which is the basically 1.8. 1.8 I can write as 9 by 5 because, okay, 9 by 5 is actually 1.8, okay. Yes. And last slide was not the syllabus. Last slide just revision of the graphs we have done, okay. Whatever you have done now, graph you did, okay, in 3 hour, 4 hour you did. I just told in the 2 minute, okay. So what we can say, C positive. C positive means I will go, I said in the last slide here, C positive how to move upside. C positive is upside. C negative downside. Okay. C positive up, C negative down. M positive this way, M negative this way. Okay. So now I can write here in this one, C positive, so upside, and then we can say slope is also positive. So my graph will be like this. This is the, okay, correct answer for the graph. Yes. And this value is here 32. If they're asking what is the 10 theta, you know, 10 theta is 9 by 5. Correct this over this graph here. Can we plot? Can you plot the next graph? Next one you have to plot, okay? And then you will check whether you are getting correct or wrong, okay? And graphs you cannot mug up. Means in the graphs, what are the thing that if I change the axis, things will be changed. So we can never mug up the graph, okay? So you have to just learn how to plot the graph perfectly, okay? That's why that graphs were told to you in the basic mathematics. Just 1 week back, it was told again, okay? I also told you here that how to do the things if you forget, okay? So now, next question for you, I'm writing here. That is okay. Written? Done na? Okay. Suppose if I give you here, this is the C and this is the F. Okay. Then what we will do? C and F. Then what we are going to do? C and F. Yes. Now we can see sir axis change. So you will write the same relation F equal to 1.8 C plus 32. Only thing that is happening here in this one, you can plot, okay? I'm also saying here that sir F is on the x-axis, so x equal to 1.8. 1.8 I can write first of all 9 by 5, okay? C is the y-axis plus 32, okay? Here C is on the y-axis. I need relation always y equal to x plus c. So we can say 9 by 5y will be equal to x minus 32. So I can just, okay, cross that side. So y will be equal to 5x by 9. But that side 5x by 9 minus here also I get it 32, 5 by 9. If you compare now y equal to mx plus c, so we can say sir c here is a negative, c is a negative, and if you say slope with the m, that value is basically 5 by 9, okay, 5 by 9. So c negative is how to come downside, okay, here, and okay, slope is positive, so I can just move like this. This is the answer here, okay. Yes, can we go for next? I hope you got the same graph. All got the same graph. Everyone got same graph. Okay, okay. Now, if you got the same graph, then you are clear here. One more graph I will ask, then we'll move to the next one. One more. Add. Suppose if I am giving here, then what is the graph between Kelvin and here Celsius? Because a Kelvin Celsius relation is very simple. C plus 273, it is nothing but like y equal to, okay, x plus 273. If you compare y equal to mx plus c, you'll find that c is positive, m is also positive. C positive is upside, okay. C means intercept, okay, and m positive. So graph will be like this is the answer here, okay. Yes. All three graphs clear. Can you move for the next one? Next. Okay. If I say one question, how, okay, in which common reading is not possible? In which common reading is not possible? Common reading, same reading, in which it is not possible? K and C, okay? If I ask in which scale negative temperature not possible? In which negative temperature not possible? Kelvin, Fahrenheit, Celsius. Answer is K. In Kelvin, negative temperature not possible. Okay, negative temperature is not there because lowest temperature in the Kelvin is 0. Somewhere you can write in Kelvin, negative temperature not there. You can write, okay, this line. In Kelvin, negative temperature not possible because lowest is the 0 Kelvin. 0 Kelvin is the lowest temperature that can be possible. Still we didn't reach it. Okay, 0 Kelvin is the lowest temperature. Okay, lowest possible temperature is the 0. We don't have negative in the Kelvin. You can write, okay, negative reading is not possible. Negative temperature not possible in the Kelvin. Okay, so we refer this Kelvin scale as absolute scale also. Okay, next one we have here scale based on triple point. Scale based on triple point. Now, here we can say, first of all, you need to know, sir, what are the triple point? Okay, it's triple point of water actually for different material, different triple point. Triple point of water is 273.16 Kelvin, or we can write 0.01 degree Celsius. Triple point will come into detail in your calorimetry chapter, but in short, I can say in triple point, solid, liquid, gas, all three states will be there, and temperature is 273.16. I need to specify pressure also, because if I only write the temperature, not okay, correct. So wherever we are writing the triple point, we need to specify both the things, temperature as well as pressure. But as of now, just remember the temperature here. Okay, we'll see in the calorimetry exact definition of the triple point. So here for us 273.16 Kelvin. Okay, now we can say in this scale, whenever we are making any scale, we need to take lower point as well as upper point. Whatever the scale we are writing, lower and upper both are required. But in the triple point scale, at 0 Kelvin, because 0 Kelvin is the lowest possible temperature, what is the 0 Kelvin definition? At 0 Kelvin, okay, this question is also asked, at 0 Kelvin what happens? At 0 Kelvin everything will freeze. At 0 Kelvin everything will freeze. 0 Kelvin, we define that whatever activities are there, activity at the your micro, macro or atomic level, activities will be stopped. At 0 Kelvin, all the activities will be stopped. Water become ice, I'm not saying. What I'm saying, what 0 Kelvin is defined as all the atomic activity to that level will be also stopped. Okay. So what are the 0 Kelvin basically? Atomic activities stops. That's it. Okay, means at there will not be any activity at all at the atomic level also. So we can say at 0 Kelvin, any of the value you take here, volume or you take pressure here, we have to take always 0. So for any scale we need upper as well as lower, but here 0 Kelvin we have to take any of the value as 0. So this lower, okay, we don't have to find this lower value. Only thing we need to find here at the 273.16, and here we can say this value is known as XTR. So this is the volume of the gas. So volume of the gas, if anyone is asking the triple, okay, what is the volume of the gas at 0 Kelvin? Volume of the gas at 0 Kelvin. What is volume of the gas at 0 Kelvin? 0, okay, 0, because volume of the gas is always, we'll write this definition, free space where molecule can move, and at 0 Kelvin there is no activity. So volume, pressure, anything we will write here 0. Okay, only you need to find that reading at the 273.16, and then we can say at any other temperature here T, this will be the XT, and after that we'll use the same method, this minus this. So XT minus 0 will be equal to XT divided by, we can write here XTR minus 0, so XTR equal to, we can write here T minus 0, that is the T, divided by, we can write 273. So from here we can write in this one, okay, T will be equal to here XT divided by XTR, okay, into 273.16 Kelvin. This is the answer here. Okay. Now we don't have to remember this formula also. We'll do one question and we'll do next question without this formula. Just you have to draw the diagram. Okay, you have to make the diagram properly, then we can find the things. Yes. So I'm writing the question now. So scale based on the triple point is having some typical name, but method is or questions based on this are very easy. Calculation is also very easy because lower always you have to write 0, 0. Like if I give you one question, okay, if value of pressure at triple point of water is 1/3 times of, okay, 1/3 they can say 1/3, okay, times of pressure at melting point of a material. Find melting point. This is the question. Language is a little bit typical if you see, okay, just read one time. Value of pressure at triple point, okay, of water is basically 1/3, okay, 1/3 of what? 1/3 of, okay, in this one, value of pressure at triple point of water is 1/3 of pressure at melting point of material. Find melting point, okay. Now we can say here in this one, okay, you have to just draw like this, here 0, and then we can write, okay, here also 0, 0, 0, okay, 0, 0. Then we can write here in this one, this is basically 273.16, and here, okay, now read. If value of pressure at triple point of water is 1/3, okay, 1/3, 1/3 times, okay, 1/3 of pressure they can say, 1/3 times they can say, whatever they want to write, 3 of pressure at melting point of material. Means if I say we have to find melting point, means this temperature T Kelvin is actually melting point of material, okay, MP of material I can say here. And at this pressure is if P, then at this pressure is P by 3. This is the meaning of the question. If we are taking here P, then here you will take how much your P by 3, okay? Here P, then here you will take P by 3, okay? So now we can say this minus this by this minus this. Now calculation is nothing. Once you are able to write this question, this language, in this format, question will be easier for you. Here you have to spend sometimes, read 2 times what they are trying to say. So we can say P divided by P minus 0 is P divided by P by 3 minus 0. So P 3 will be going upside. Equal to, we can write here T minus 0 is T divided by, we can write here 273.16. Now is a PP cancel, so T becomes basically 3 into 273.16 Kelvin. You can multiply, that will be your answer. Okay. So in scale based on the triple point, only thing that is the important is the language. Other things will be much easier. We can write some more questions here, but we are not writing because ultimately in the final examination we are going to get questions mainly from the KTG as well as thermodynamics. So this much information is enough as of now. We'll write now thermal expansion. Okay, I hope this question is clear to you. This type of pattern, whenever triple point is there, one thing you have to do always is the 0 0 you have to write. Whenever a scale based on the triple point is there, you have to do all the time. Okay, lowest point you have to write 0 0. Okay, lowest point will write 0 0, then only will proceed for the questions. Right, next one, thermal expansion. Thermal expansion. Now, right, generally substance expand on heating. Generally substance expand on heating. If you say, I am saying generally substance expand on heating. Okay, okay. So some of the substance will be okay, some will expand, but is there any contraction? I am heating. Can you give name of any material? Means I am heating, but I am observing contraction. I am heating. Okay, I was expecting there will be the expansion, but there is some contraction. Can you give name of that material? Probably everyone has seen, you know. Okay, I am heating, but I am getting the contraction. Yes. In iron, where you have seen contraction, we are heating, we get the contraction. In iron, if I take iron rod and if I heat, then we get the contraction. Have you seen this thing? Which I am saying you have seen. Rubber is the example. Okay, if you heat the rubber, then contraction is there. But iron, I don't think that you have seen. Okay, which type of iron rod you have seen? Water also is there, but water we may not have seen. Okay, but rubber we have seen. Okay, in water also in certain range contraction is there. Okay, not in the okay throughout the okay in one particular range is there. In rubber it is there. Okay, in rubber actually. Okay, so some materials have some bonding. Because of the bonding only this thing happens. But usually if I say generally substance expand on heating. Generally. So we are talking about 99% of the materials. So 99% we can say they expand. That's why this chapter name is also expansion. Okay, and iron is not the example. Iron expands. Okay, so we can say generally substance expand on heating. Okay, because interatomic separation increases. Because interatomic separation increases. Because interatomic separation increases. Okay, later on I will tell okay that why water contract. So for that we'll be having separate things. Okay, now we can have the expansion can be in the solid also, can be in the liquid also, can be in the gases also. Okay, solid expansion of solid, expansion of liquid, expansion of gas. But if I say that we have length, expansion in the length, expansion in the area, expansion in volume. So all three types of expansion, the length means linear expansion, areal expansion, volume expansion. These three expansions are valid for liquid and gases. Liquid and gases, these are not valid. For the liquid and gases, we will be having only one, that is your volume. But for solid, we will be having your all three types of expansion. Means we have here linear expansion, okay, linear expansion. Will be having here, okay, areal expansion, that is also known as your superficial expansion, and this is the volume expansion. Okay, now these three expansions are just categorized, but actually they are, okay, linked with each other. If I say that I have some one rod, okay, very, okay, means the length of this rod is huge, okay, 1 kilometer rod, suppose. In that width as well as height of the rod will be very, very less. So if I heat, then I will get significant change. I will observe a significant change in the length. However, there will be the change in the width also, change in the width as well as change in the height also. Okay, in all three changes will be there. But I will only consider change in the length. So I can say linear expansion. Okay, means when I am taking expansion in one dimension only, then I say linear expansion. When I am taking 1D in one particular, okay, either I am taking in the length, either I am taking in the width, either I am taking in your height, in one particular direction I am taking the change, that is the 1D. If I say, suppose I got here, okay, this, okay, I got this plate, okay, square type plate, or I got, suppose, okay, like this, I can take example of this mobile here. So in this one, we have, this is the, okay, suppose this is the metallic plate, okay, not the, okay, this mobile here. This is the, okay, we can say length and width. Its thickness, or we can say its height or thickness is negligible, okay, negligible, suppose. So when I will heat, then what will happen? This dimension will change, this dimension will change. So there will be the change in the two dimensions. Third dimension is insignificant, that I will not consider. So when two dimensions combinedly I talk, then I say areal expansion. And if I have, suppose, cubical block, okay, if cubical block is there, then what we can say, that there will be the basically change in the all three, just like this one is there here. Okay, so you can say in this one, this dimension, okay, suppose like this is there, this is the metallic, suppose, okay, you have to assume metallic. So the L, B as well as H, then we can say basically your all three dimensions will be changed. Okay, so this one is known as your 3D. Okay, so when I said a 3D volume expansion, it means in that one linear is already there. Okay, your areal is already there. Now we can say that what are the linear quantities? If you express in the meter, these are the linear quantities. Like if you say length, width, height, diagonal, thickness. Thickness, most sometimes for the thickness, sometimes people say 2D quantity. Thickness is also 1D quantities. Diameter, 1D quantities. Circumference, 1D or 2D. Circumference is also 1D, because wherever circumference you will find, you will write always in the meter or centimeter. You will never write meter square. If you are writing meter square, means 2D. If you are writing meter cube, then 3D. Okay, so this is the one we can, okay, we can at least differentiate. Then we can write here change in length is proportional to initial length. Okay, as well as temperature change. If you increase temperature by huge amount, then we can write change will be also more. Then we can write delta L, some constant will be coming. So L naught alpha delta theta. Okay, here delta L is basically known as change in length. Okay, L naught is known as initial length, and delta theta is the temperature change. Then you might be asking what the alpha. So alpha, we can say this is the coefficient of linear expansion. Okay, coefficient of linear expansion. Here unit we need to remember, unit as well as dimension. So dimension you will see in the dimension chapter, but unit at least I can say. So unit I can write alpha will be equal to, you can say, Sir, this will be delta L divided by L naught delta theta. This is meter, meter cancel. So only 1 by degree Celsius will be left. So we can say per degree Celsius or per Kelvin will be the things. Okay. So this formula you need to remember, delta L equal to L naught alpha delta theta. Same way we will write here that such change in area will be proportional to initial area as well as temperature change. So we can say delta A will be equal to here A naught beta delta theta. Other things remain same, only beta is coming, and we can say beta is basically here. Okay, what you can say, sir, this is the coefficient of, okay, aerial expansion, or we can say superficial expansion. Okay, and same way I can write for here, if I have cube is there, sphere is there, okay, when I will be having when I'm going to consider all three dimensions, we can say delta V will be equal to here V naught gamma delta theta, and this gamma is basically equal to, we can say, okay, this is the known as coefficient of volume expansion. Okay, volume expansion. Now we can say alpha is for 1D, beta is for 2D, and gamma is for 3D expansion. Alpha for 1D, beta for 2D, this is for 3D expansion. We can write, if this is alpha for 1D, for 2D it should be 2 alpha, and for 3D actually it should be 3 alpha. For 1D if it is alpha, for 2D it should be 2 alpha, and for 3D it should be 3 alpha. It means we can say this beta actually must be equal to 2 alpha, beta must be equal to 2 alpha, and gamma must be equal to 3 alpha. Okay, beta must be 2 alpha and gamma must be 3 alpha, because for the 1D alpha, for the 2D 2 alpha, for the 3D 3 alpha. It means beta must be 2 alpha, gamma should be 3 alpha, and we can say alpha beta gamma ratio here, that actually becomes 1 to 3. Okay, always you have to remember this thing, that alpha beta gamma ratio is 1 to 3. I will take some questions on this. I hope you have written all the things. These are very basic things, probably you know also, because you are not in the 11th class, you are in the long term. So all the formula we have to remember delta L, delta A, and delta V here. Okay, yes. So I'm taking the next question. Then I take, if gamma equal to 12 into 10 power minus 5 per degree Celsius, find beta. Whenever they give question like this, first of all you have to find the alpha. Gamma we can say, sir, gamma is nothing but the 3 alpha. So gamma equal to 3 alpha equal to 12 into 10 power minus 5. Actually I should not solve this question. This is the 4 into 10 power minus 5. Yes, sir, beta is nothing but the 2 alpha, and we got here 8 into 10 power minus 5. Okay, so very easy question, actually nothing is there. Okay, this question means you will read and you will get the correct answer. Okay, this is correct, done. Okay, like this. Okay, so can I tell the next question in this topic? Next one. Yes. So if any alpha beta gamma is given, we can do. Next question is very popular one. They have asked multiple times in your NEET examination, multiple times, not only one time. Okay, same question, because question cannot be changed, so they change the options. They changed, and they have only changed the options, because concept no one can change. What they are saying in the question I will write. Okay, they will say that two rods with length L1 and alpha 1, this is the L2 and alpha 2, are kept as given in figure, or kept on each other like this. If they will give you, if difference of length, remain same, at all temperature. Difference of length remains same at all temperature. This temperature becomes very, very low, very, very high. Difference of length, that is the delta L here. So this difference, that is the delta L, which is the basically L1 minus L2. This remain always constant. Means suppose this value is 10 centimeter, it remain always 10 centimeter. Okay, difference of length remains same at all temperature. Means if this is the suppose 20 centimeter, this is the 10 centimeter, difference is 10 centimeter, difference remain 10 centimeter. What the meaning of this thing? If you think, you can say, sir, if this second rod is expanding by 3 centimeter, then this upper also will expand by 3 centimeter. If this one is suppose expanded by 1 meter, upper also will expand by 1 meter. If both having the same expansion, then what will happen? Then only difference will be same. If both are having same expansion, then only difference will be same. Or I can prove mathematically. If I say for the change, we do the differentiation. Okay, general meaning of the differentiation is change. So I can say L1 change will be how much? Your delta L1. Here change will be delta L2, and in constant change is 0. So we can write here delta L1 will be equal to delta L2, and this also confirms the same thing that change must be same in both rod. Delta L1 we can write here L1 alpha 1 delta theta, and here we can write this one becomes L2 alpha 2 delta theta. Delta theta delta cancels. We got L1 alpha 1 equal to L2 alpha 2. Okay, L1 alpha 1 equal to L2 alpha 2. Okay, this is the relation that you have to remember. L1 alpha 1 equal to L2 alpha 2. Okay, one time they asked this thing, L1, this relation was given. Then they asked this one, second time, alpha 1 by alpha 2. So you can say alpha 1 by alpha 2 is nothing. We can write how much? L2 by L1. Alpha 1 by alpha 2, we can write L2 by L1. Third time, okay, this was also asked. They said plus 1 both side. If I do plus 1 both side, then you can say, sir, here we'll get alpha 1 plus alpha 2 divided by alpha 2. And this side I can write L2 plus L1 divided by L1. Now, they have asked this option also. This option also came in the examination. They asked 3 to 4 times the same question, the same pattern, by changing the option. Can I do minus 1 both side? Because this thing they have not done. Suppose next time they are doing the minus 1, because minus 1 they have not done. So we can say minus 1 if I do in this one. So you can write alpha 1 minus alpha 2 divided by alpha 2 equal to, we can write here L2 minus L1 divided by L1 we can do. Okay. And one more time they give the numerical also on this. They said that if okay, I'm giving the okay, L1 equal to 10 centimeter, L2 equal to, they give, okay, here I can take 6 centimeter, and they said alpha 1 equal to 8 into 10 power minus 5. Find alpha 2. Okay, they ask alpha 2. We can use the same relation L1 alpha 1 equal to L2 alpha 2. Then we can say L1, that is the 10. This is the alpha 1, 8 into 10 power minus 5 equal to L2. We know 6. Alpha 2 we have to find. Can you find now? Yes. We can solve now. Calculation you can do. I don't have. If you can say, sir, this will be your 40 by 3. So alpha 2 becomes your 40 by 3 into 10 power minus 5 per degree Celsius. This question also, okay, they have asked pattern is same. They are not changing the pattern, just okay, switching from one to other. Okay. Yes. Can I give you one homework based on this? Homework based on this concept, because whatever homework I am giving, that also they have not asked. Okay. That pattern they have not asked till now. Maybe in the future, whenever they will see, okay, this is also possible, they can ask. Up to this, whatever written here in this board, previously they have asked. Okay. 16 they asked, then okay, in 20 they asked this thing. This was, I think, in the 20 came. Okay. Can we convert into meter? Both side, this is centimeter, this is centimeter, so conversion not required. Okay, this is centimeter, this is also centimeter, so no need of conversion. Okay. Yes. So one question I am giving, okay, for okay, homework you will try. Half question I will solve. Okay, listen. So they will give the same thing that they are saying difference of length is 10 centimeter. Difference of length is 10 centimeter. Find L1 and L2. Okay, and they have given alpha 1 equal to, okay, in this one, then I can take suppose 6 into 10 power minus 5 per degree Celsius, and alpha 2 they have given here in this one 8 into 10 power minus 5 per degree Celsius. This is the L1 alpha 1, this is the L2 alpha 2. You can say, sir, here L1 minus L2 is given 10, and if you have to solve L1 and L2, then you need two relation. Two equations are required, but only one is given. I need 2, they have given only 1. Okay, I need 2, they have given only 1. L1 minus L2. You need another relation to solve this question. What we can do? You can say I can make other relation from here. L1 by L2 will be equal to how much here? Alpha 2 by alpha 1. Previously we did this condition. One equation is given in the question. Sir, difference of length remain always 10 centimeter. Is L1 minus L2 is 10. Other relation we need to make from here. So we can say L1 by L2 will be equal to alpha 2 by alpha 1. This is the 8 divided by how much? 6 is 4 by 3. You can say I can take, sir, L1H 4x, L2H 3x. You will put here, sir, 4x minus 3x equal to 10. It means x equal to 10. Once you got x equal to 10, you can say, sir, this is the 40 centimeter and this is 30 centimeter. Okay? Yes, clear? Are this question also clear now? This question till now they have not asked, and they might ask, okay, whenever, okay, their mood will be there, they may ask. So now we'll go for next question, percentage change. That is quite important for us, okay, and somewhere we are doing mistakes also in the questions of percentage change. I have seen most of the people doing the mistakes. So we are going to write percentage change questions. Listen, if I say percentage change in length, so you see, sir, percentage change in length means change divided by initial into 100. So there will be L naught alpha delta theta by L naught into 100. It actually becomes alpha delta theta into 100. Okay. Same way I can write percentage change in area. So you can say, sir, same thing, change in area divided by initial area into 100, because percentage change is always expressed like this, change by initial into 100. Delta A we will write here A naught beta delta theta divided by A naught into 100. A naught cancelled, so we got here beta delta theta into 100. Same way we can write here percentage change in volume. So percentage change in volume, if you say, then we can write delta V by V naught into 100, and then we can write V naught gamma delta theta divided by V naught into 100. V naught cancelled, so we got here gamma delta theta into 100. Now we can say that beta delta theta we can write as 2 alpha delta theta into 100. This can be written as 3 alpha delta theta into 100. Alpha delta theta into 100, 2 alpha delta theta into 100, 3 alpha delta theta into 100. You will remember like this, sir, in 1D, alpha delta theta into 100, 2D, 2 alpha delta theta into 100, 3D, 3 alpha delta theta into 100. We said 1D if 1%, 2D 2%, 3D will be the 3%. Okay, like this you will remember. Okay, 1D 1%, 2D 2%, 3D 3%. Like if I say here question that if percentage change in radius of a sphere. So percentage change in radius of a sphere is, suppose if I say 1%, then you can say, sir, radius 1%, it means area 2%, volume 3%, just 1, 2, 3 we can use. Okay, so I'm giving here 0.5%. 0.5%. I am asking percentage change, then then percentage change in area. So percentage change in area will be how much? If radius is 0.5%, then what about the your area? You can say, sir, area is 2D quantity, so just double. Just double means we can write 1%. Then I'm asking percentage change in volume. So volume we can write how much? Three times. Directly we can write here your 1.5%. Okay, 1.5%. Percentage change in diameter, and here people do the mistakes. In diameter, what you will say? Diameter. Diameter you have to say. Diameter is 1D quantity or 2D? or 3D? First, you need to be clear in this 1D, 2D, or 3D. 1D, na? So it will be same 0.5%. Here people do mistake. They give region like this. So D equal to 2R. Diameter is 2 times of radius. And if diameter is 2 times of radius, so it should be double. But no, for the percentage we use this method. We write always D proportional to R. Whether 2 times or 10 times or 100 times or million times, we'll write D proportional to R. And then we'll use the change method delta D by D into 100 equal to, we'll write here delta R by R into 100. Okay, this way. So it means percentage change the radius is same as your diameter. I hope this thing is clear. Yes, whatever we have written here, any problem in this? Okay, can I ask next question? Next one. Next. Okay, listen, I'm asking next question here. Two sphere, okay, two sphere, okay, of same material. They have given same material and they have given same temperature change also. Okay, temperature change is also same, because you know percentage change actually depends on alpha, delta, theta. Okay, yes, 2 will not be included. Okay, this 2 we will not take, even though 3, 4, 5 anything is written, will not be taking. One example I am taking on this. Two sphere, one sphere is this, one sphere is this. This diameter is D1 and this diameter is D2. We can say D2 is basically equal to 3 times of D1. Okay, this relation is given. They can say 3 times, 4 times, 10 times. Then they are writing if percentage change in diameter of first is 1%, then find change in second. Okay, this is the question. So we will write the same way, sir, D2 proportional to what? D1. And then we'll write delta D2 divided by D2 into 100 will be same as delta D1 by D1 into 100. You know that, okay, material is same, material is same, temperature change is same, so it will remain as same, it will be always same. Yes, so this will be same as 1. Okay, clear? Yes, I hope this question is clear. If temperature, next question, temperature of a sphere. So suppose here 100 times also coming, then also will be same. Okay, if temperature of a sphere is changed by 20 degrees Celsius, its volume changes by 1.2%. Okay, find alpha, find linear expansion coefficient. So this is the question. Find linear expansion coefficient. Read the question. If temperature is changed by 20, you will say, okay, what you will say here, sir, percentage change in volume is how much? Percentage change, okay, in volume is always equal to 3 alpha delta theta into 100, which is actually equal to 1.2. Okay, so you can say, we will write here 3 alpha, how to find delta theta is how much here? 20 into 100 equal to, I can write this one as 12 by 10. Okay, decimal removed. Here I can say 3, this becomes how much here? 4. Then we can say, sir, alpha will be equal to, okay, 4 divided by, I can write, this will be how much here? 2 into 10 power 3, one more 0, so 10. This becomes alpha finally 2 into 10 power minus 4 per degree Celsius. So I hope these simple questions on the percentage can we do? This calculation you can say I did a little bit fast here. I was somewhat fast in the calculation part. 3 alpha delta theta into 100, 1.2. Then 12 by 10, 1.2 decimal removed. And then 3 alpha delta theta is 20, 100. And then, okay, 4 divided by 2000, 102 into 10 power 3 into 10. and then 2, 4, 2, this 10 power minus 4. Yes? Okay, so bye. I think sir might be waiting. Okay? Then up to this, okay, things will be asked. Okay? Tomorrow onwards, it will be there. Okay? Whatever is there, it will be told to you. Okay? Yes. Okay, so bye. Practice these questions on the percentage, and thermal expansion is not over yet. Just we started. It will take some more time. Okay? So basic things we have written.